Today we have to study the converse, inverse and contrapositive of the compound statement. If the conditional statement is P implies Q, then its converse statement is Q implies P. Inverse is negation of P implies negation of Q, and contrapositive is negation of Q implies negation of P. We have to write the converse, inverse and contrapositive statement of the conditional statement only. Now we have to see the example. Question is, write the converse, inverse and contrapositive of following statement. The statement is, if a function is differentiable, then it is continuous. First we have to write this statement as separate simple statement as P as a function is differentiable and Q as a function is continuous. Then negation of P is a function is not differentiable and negation of Q is a function is not continuous. Now we have to write the converse of this statement as in the form of Q implies P. If a function is continuous, Q is a function is continuous, then P is differentiable. That is, converse of the given statement is, if a function is continuous, then it is differentiable. Inverse is negation of P implies negation of Q. If a function is not differentiable, negation of P is not differentiable, then negation of Q is it is not continuous. That is, the inverse of given statement is, if a function is not differentiable, then it is not continuous. Next, contrapositive statement is negation of Q implies negation of P. If a function is not continuous, then it is not differentiable. In this way you have to write the converse, inverse and contrapositive of the given statement. And हा क्वेश्चन 3 मार्कासाठी तुम्हाला विचारला जातो. 2 साठी विचारायचा असेल तर मग यातलं कोणतेही 2 इनवर्स कॉन्ट्रापॉझिटिव्ह किंवा कन्वर्स कॉन्ट्रापॉझिटिव्ह असे कोणतेही 2 स्टेटमेंट लिहायला विचारले जातात. याच टाईपचे तुम्हाला एक होमवर्कसाठी एक्झाम्पल दिलेले आहेत, ते तुम्ही सॉल्व करा. Now to see the algebra of statements. It is also said to be rules of logic. First is idempotent law, that is P or P is logically equivalent to P and P is also logically equivalent to P. That is, here the disjunction and conjunction, but both statements are same, then result is same as the P statement. Next, second law is commutative law, that is P or Q is logically equivalent to Q or P. P and Q is logically equivalent to Q and P. Here we have to change the position of the statement P and Q. Here Q and P, the value of result is same. This is said to be commutative law. Next, third is associative law. Here see, P or in bracket Q or R is logically equivalent to P or Q or R is also logically equivalent to P or Q or R, and P and Q and R is logically equivalent to in bracket P and Q bracket complete, and R is also logically equivalent to P and Q and R. See here, both the symbols are same, or here and then we change the bracket, the value of resultant statement are same. Next, fourth law is distributive law. Say P or Q and R is logically equivalent to P or Q and P or R. Here see, both symbols are different. Here is or, here is and. In this case we have to take separate two brackets as P or Q and P or R. Similarly, P and Q or R is logically equivalent to P and Q or P and R. This is said to be distributive law. Next is De Morgan's law, that is negation of P or Q is logically equivalent to negation of P and negation of Q, and negation of P and Q is logically equivalent to negation of P or negation of Q. This law is seen negation of conjunction and negation of disjunction. Next is identity law. This say P and true is logically equivalent to P. See here in truth table, here P is true, false and T as true, both are true. Here P and true is equal to and, that is conjunction, and rules of conjunction is both are true is true, otherwise false. Here both are true, therefore it is true. Here P is false and true is logically equivalent to false. Therefore, see, the truth value in this column are true and false, which are same as P. Therefore, P and true is logically equivalent to false. Similarly, P and false is logically equivalent to false. See in table, here false is both are false. Therefore, P and false, that is and conjunction, rules of conjunction is both are true is true, otherwise false. Therefore, P true and false is equal to false. P false, P is equal to false, that is both are false. Therefore, P and false is logically equivalent to false. Next, P or true is logically equivalent to true. See here, P or true, P the true, that is disjunction, and truth value of disjunction is both are false is false, otherwise true. See here, P is true, true or true is true. Next, false or true is true, that is both are true. Therefore, P or true is logically equivalent to true. Next, P or false. See, P or false is true. False or false is false, that is both are false. Both are, first is true, second is false, same as the P. Therefore, P or false is false. This is said to be identity law. Next is complement law. This is P and negation of P is logically equivalent to false, that is contradiction, and P or negation of P is logically equivalent to true. See in table, truth value of P are true, false, negation of P are, negation of true is false and negation of false is true. Here P and negation of P, that is conjunction, and truth value of conjunction is both are true is true, otherwise false. Here first is true, second is false, therefore false. First is false, second is true is false, that is both truth values are false. Therefore, P and negation of P is false. Next, P or negation of P is logically equivalent to true. P or means disjunction, and rules of disjunction is both are false is false, otherwise true. Therefore, true or false is true, false or true is true. That is, this is the complement law. P and negation of P is logically equivalent to false, and P or negation of P is logically equivalent to true. Next is the absorption law. See, P and in bracket P or Q is logically equivalent to P, and P or in bracket P and Q is logically equivalent to P. In this rule, see, the symbols are different, but the two statements P are same. The two statements P are same. Then in this case we write the result as P. Next is conditional law. See, P implies Q is logically equivalent to negation of P or Q. This is the conditional law. The meaning truth value of P implies Q are same as the negation of P or Q. Next and last is the biconditional law. There are two laws for biconditional. P biconditional Q is logically equivalent to P implies Q and Q implies P, or it is also is equal to negation of P or Q and negation of Q or P. These are the 10 laws for algebra on statements.